Hello, today we are going to talk about how to simplify expressions. Before we get into the lesson of simplifying expressions, it's very important that we understand what a term is. We've discussed earlier about the different parts of an expression. You know, there's terms, there's the coefficient, the constant, variables, obviously. But I want us to focus on terms, and I want us to understand that terms will be separated by either addition or subtraction. So what you see in this algebraic expression are several terms. In fact, there's 1, 2, 3, 4, 5, 6, 7 terms. And each term has been separated by either addition or subtraction. So what we're going to do is, or hopefully do, is be able to combine like terms. All right? Like terms are basically terms that have the same variable and same exponent. So now that we've identified that there's 7 terms, I want us to go in and find the like terms. If we look at the first term, we have 8 times x to the second power. So as we read the rest of this expression, we're looking for a term that also has x written to the second power. And here it is. So 8x to the second power, take away x to the second power, or what we would call like terms. Another set of like terms, we see 14, the constant 14. We also see another constant of -7, or take away 7. So the fact that we have 2 constants, both numbers without a variable, means the positive 14 or plus 14 and -7 would be another example of like terms. Another pair of like terms that I see is 3x and 5x. Both terms have the variable x. Both are raised to the first power. Therefore, 3x plus 5x are like terms. The only term that doesn't seem to have a pair or a partner is y. It's important to know that like terms can be combined, and it's very simple to combine like terms. All you would do is add the coefficient, and then you keep the common variable and exponent. So I'm going to focus on the last pair that I found, 3x plus 5x. We have 3x, and we're combining it with a positive 5x. Well, if I follow the steps, I will simply add the coefficients, 3 and 5 to get 8. Keep the variable and exponent. Well, the variable that they had in common was x. There was no exponent, so my solution, 8x. I can also combine 8x squared minus x squared. If we have 8x squared and we are subtracting x squared, step number 1 says to add the coefficients, but sometimes you have to subtract the coefficients. There's an understood 1 here, so 8 minus 1 is 7. Keep the variable, keep the exponent, 7x to the second power. All right, so what we're going to do now is use this information about combining like terms to simplify expressions. When you're given an expression like this one and they ask you to simplify it, there's basically 2 steps. The first step is to check for the distributive property. If there's a place where you could use it, you would use the distributive property. Second, you would then combine your like terms, and we just talked about in detail how to do that. A lot of times I tell my students to think about DC, or let's go to DC. You must first do the distributive property, followed by combining like terms. So we have D and then C. So what we're going to do is check for distributive property. Here, the distributive property could be used. I can distribute the 3 to the x. That is 3x plus 3 to the 4. That is 12. Then I just simply copy the rest of the expression. That would be step 1. Step 2 is to then go back and combine your like terms. So first we have to identify the like terms. I see 3x here. Take away x. Both terms have an x. The x is being raised to the first power. So in this case, I will subtract my exponents, my coefficients. So 3 minus 1 is 2. keep the variable x. I see another pair of like terms. We have positive 12 plus 2. Well, 12 plus 2 is 14. We can't really simplify any further because one has an x, one does not. So the simplified expression would be 2x plus 14. Now, sometimes it can get a little tricky. When it gets a little tricky is when they throw in division. Sometimes the students tend to forget the very basics of combining like terms, and that is that your terms are separated by either addition or subtraction. So when you're given an expression, you might want to look for those addition and subtractions and then identify your terms. There's actually 3 terms in this expression. 1, 2, 3. Problem is that we can combine these two, or we can break this term down even further. Right now it says 6x divided by 2, but we can divide 2 into 6 to give me 3x. All right, copy the rest of the expression. Now you look for your like terms. We have 3x and 4x. 3x plus 4x is 7x. The constant 7 can't be combined with anything else, so we would copy it, making my simplified expression equals 7x plus 7.